Hi, my name is Jakub, and I'm front-end developer at Frontend House and your today's host at Expert Zone. In this episode of Expert Zone, I'll show you how to create a simple Skype-like video calling application that runs in your browser using WebRTC and JavaScript technologies. Let's kick off by looking at the agenda. First, I'll talk about what WebRTC is and how you can use it. Then, we'll take a look at core architecture of our application. We'll also explain what dialing flow looks like and how to take this to our advantage. I'll also talk about what ICE candidates are and how to exchange them. Then, I'll talk about stun and turn servers and what they are. And then we'll jump into live coding to learn about WebRTC API. First, let's take a look at definition provided by Wikipedia. WebRTC is a free, open source project providing web browsers and mobile applications with real-time communication, using simple programming interfaces. What this means for us is it will be our main tool when it comes to creating peer-to-peer applications like video calling applications, screen recording applications. It's also used in game development, so there's a lot of uses. I would also like to show you what is the current support when it comes to all the browsers. As you can see, it is nearly 94%, and it is more than enough to run in all the modern browsers. Now, let's take a deeper look at what dialing flow is, and I'll show you step by step what are all the necessary steps that we will need to take to create a video calling application. As you can see, there are three main pieces to our application. There are two front-end applications marked as two purple rectangles and one back-end application, our signaling server. Also, for the remainder of this video, I'll refer to two front-end applications as a caller, which will be Joe, and he will call Lucy, another front-end application. Now, once the connection is established, we won't need our signaling server anymore. Peers will be either connected directly or via a turn server, but I will explain that later. Now let's understand each step of the dialing process. First of all, we need to get camera and microphone permission. This isn't related to WebRTC yet and is a standard procedure in such applications. Now, the fun part begins. Joe initializes the call by pressing the call button, where WebRTC offer is being made and sent over the signaling server to Lucy. Lucy's computer starts ringing and she will press the answer button, where WebRTC answer will be made and sent over the signaling server to Joe so he can acknowledge the answer. Does it mean that they can already start chatting? Well, not yet, because for now they only exchange basic information. Like for example, Joe exchanged information that he wants to share his screen at the resolution of 900 by 900 and he wants to do so at 20 frames per second. This isn't enough just yet to make a video call. To establish a video call, we still need to exchange ICE candidates, and I'll quickly explain what they are. ICE is Interactive Connectivity Establishment, which is a technique used in computer networking to find ways for two computers to talk to each other as directly as possible in peer-to-peer networking. What this means for us is that we won't need our signaling server anymore. Computers will simply talk with each other directly. For that, we need to understand two more words. One of them is the stun server, which stands for Simple Traversal of UDP through NATs, or simply put, Session Traversal Utilities for NAT. What this is it's a standardized set of methods, including a network protocol for traversal of network address translators. Let's take a look at the definition. Stun is a standardized set of methods, including a network protocol for traversal of network address translator gateways in application of real-time voice, video, messaging, and other interactive communications. What this means is it will help us find a direct route between two peers. But sometimes this won't be possible because, for example, Lucy's computer might be hidden behind, for example, a firewall, and direct communication won't be possible. In this case, we'll use turn servers, which stands for traversal using relay NAT, which is a protocol that exists in traversal of network, address translators, or firewalls for multimedia applications. There are some public stan and turn servers that you can use and that are listed here, but it isn't encouraged to use them in your production application. They are meant only to be used for testing purposes, so keep that in mind. Now let's go back to our diagram. We left off at exchanging basic information like the screen resolution and so on, and now we have to establish a direct connection between two peers. This is where ICE candidates will be sent from turn and stan servers to the browser, and we have to send them over the signaling server to the other peer, and they can either accept candidate or reject it. The call will start as soon as both peers agree to a single ICE candidate. Note that Joe and Lucy start sending ICE candidates simultaneously. This process occurs many times because stan and turn servers always look for a better solution even after the connection is established. The last step that we need to make is to display the media stream that is sent over to our browser on both peers. Simply put, we need to display the video. And that's enough of theory. Now let's jump into live coding to learn about WebRTC interface. I've already prepared some basic UI of our application, so let's take a look at the HTML file that I have here. The most important thing to note here is that I have two video elements. One would be to display preview of our camera, and the second one will be to display the video that is sent over the other peer. I also have simple empty users list, as well as a call button that we will press to initialize the call. I've also added Socket.io library, which I'll be using to communicate both peers over the signaling server. Keep in mind that it isn't mandatory. We don't have to use Socket.io library. We can use, for example, REST API if we want to, but the natural way of real-time applications is to use WebSockets, so I'll go with this one. I've also included our main script handle on the client-side code, and that's it for the HTML file. Let's take a look at the server-side code that I have already prepared. Most of our task will remain on the client side, so the server-side code isn't really that exciting. What it takes care of is it serves our HTML file, as well as provides basic Socket.io interface. The most important thing here is those three events that we will send over the signaling server. One will be the media offer, which will occur whenever the call button is pressed. The media answer that will handle the event whenever the call is being picked up. And we also have one event for the ICE candidates exchange. Now, there's not really a lot more going on the server side. As I mentioned, all of our application will be on the front-end side. Now let's go to our client-side code. I have already prepared some of the code that is hidden underneath here, and it's all the things that are unrelated to the WebRTC technology. So things like the Socket.io events, as well as some DOM manipulation that will just be necessary to run our application. I have this all prepared because I want to solely focus on the WebRTC API. And the entry point for our WebRTC application would be the RTC peer connection object that accepts a configuration, and we have to pass ICE servers here. And as I mentioned previously, we can define, well, ideally we would use a server that we own. For the case of this application, I will just use a public server, which looks something like this. Now this should be enough to create our basic peer and enable us the WebRTC peer-to-peer communication. Let's also connect to our WebSocket. I'll use the global object IO injected by the HTML file. Let's connect to our localhost, which should be running at the port of 3000. Now, I have already added an event here for whenever the socket is being connected, and it calls the onSocketConnected function. So let's write this one. So this will be a function, and first of all, when we connect to our WebSocket, we will gain access to microphone and camera of our device. So let's add variable constraints. And we'll say that we want audio as well as video. And this should be an async function. And right now we will get the permission for both video and audio. So we have to use the getUserMedia function. It would be media devices, getUserMedia, and we will pass in constraints. And we need to await for the result. As a result of the getUserMedia function, we'll receive a stream object. Right now we can attach our stream to our local preview video. So let's get our local video element. And let's append our stream to it. So this should already display our local camera view after the permission is granted to the user media. Right now, once we have the stream object, we can append it to our entry point of the peer application. And that would look like this. We get tracks of the stream, we iterate over them. So we have a track, and we type peer at track, and we also append the stream here. So this should display our local video, as well as we already have the stream added to our peer, so it's ready to be sent over the signaling server. Now let's handle our call button. So this would be, we need to get the element of call, which is our call button. We need to add event listener. At the beginning, we need to create our offer that will be sent over the signaling server. So let's create a variable called local offer. We'll use peer create offer. And this is an asynchronous function, so we need to await for the result. Let's also add async over here. So both peers will have two descriptions. One will be the local description, and we'll also have the remote description. And for now, for this peer, we can only set the local description, and we can do so like this. Peer set local description, and we'll create new RTC session description, and we will pass in local offer. So right now our local peer is just knows the basic configuration that will be sent over the signaling server. Last thing that we have to do here is to send our local offer over the signaling server, and I have a function prepared here And basically all it does is it uses socket.io to send it to the signaling server. And so we can get it from the other peer. Right now, we basically left the Joe's computer and we have to react to the offer on the other side. And we do so by reacting to socket.io event, which I have called the media offer. We'll pass in a second function here. So this is the description, the local that we were sending over to Lucy's computer. And here it was local description because it was our locally generated configuration. But for Lucy's computer, it's a remote description. So we take the local offer and we have a peer, but note that this is other peer because this is basically a second client. So this is different peer than we were using right here, right? On Lucy's computer, this code isn't invoked at all, and it still should work. So we can set the remote description. And we will pass in local offer. And right now we have to create the answer. So we can create a variable called answer, and we will await, and this also has to be an async function. We will create answer. The local description of this computer will be our answer. So we can basically copy the code from here. And just instead of the local offer, we will pass in answer. Right now we're on the right side of our diagram, and we can assume that Lucy already pressed the answer button and need to send the answer over the signaling server to Joe. And I will use the function that I have already prepared, set media answer, and I will pass in the answer. Right now, we still have to, I believe media answer is the name of the event I called it. We will react on the media answer event. And for Joe's computer, we only set local description so far. We still need to set the remote description, and the remote description here will be the answer that we have sent over the signaling server. So it will look like this. We'll get the answer, we'll set we don't introduce any new code. We are we can reuse this line, so we can use peer set remote description, and instead of local offer, we will pass in answer. And that's it for the dialing flow. And if you remember from the diagram, now ICE exchange process should happen. And this is easy to implement in our code. Basically, the way it works is that I believe on ICE candidate is what the event is called, and basically it will give us the ICE candidate as an argument, and it is sent over from the stun and turn servers, and all we have to do right here is to send it over to the other peer. We assume that if this event was invoked, that this peer agrees on this ICE candidate, so we don't have to do anything at all. Everything is handled under the hood by the browser, and the only thing that we have to do is to react to the event that is being emitted once the send ICE candidate function invokes, and it is remote peer ICE candidate. And actually I have now noticed that I have made a mistake. So this should be whenever we are reacting to socket, we will have a data object, and we can access it like this. I believe this is fine now. We'll see if the code works. It's here. Oh, and actually this should be an offer. This should be answer. Yeah, that's fine right now. And right now we have to test if the ICE candidate that we sent over here is good for this peer. And we do so by creating RTC ICE candidate. And we pass in the candidate that we sent over from the other peer. And let's also make this function on async. And this will generate a lot of errors because whenever this peer don't like an ICE candidate that is sent over, it will just throw an error. So it's basically mandatory to wrap it at least in a try catch function. And well, we don't actually have to do anything with the error here. If we want to, but basically we can just dismiss all the errors, and a new candidates will be sent over, and finally one of them should be accepted by the peer. The last thing to do is to add the ICE candidate to our peer. And you can do so by invoking add_ICE_candidate function. We will pass in the candidate. This is actually the line that that might throw errors, so keep that in mind. And by this point, all the communication should be already established. And the last thing that we have to do is to attach the media stream that is sent over through the peer-to-peer communication. At this point, the only thing that we still have to do is to attach the stream that is sent over the peer-to-peer communication. And once our browser will receive the media stream, an event will be invoked, and it is called track. So we'll basically receive the stream through this event. We can now get our remote video element, which has an ID of remote video. The stream will have a property called streams here, and we can basically get the first stream from this object. And now that we have both the stream and the remote video, we can set the source object to our stream. It's basically everything. By this point, we should have our application ready to go. Right now, you can see that I have two client applications opened, and basically you can refer to them as, for example, this would be our Joe, and this would be Lucy. And locally for testing, we can achieve that by running just one browser in incognito and or in private mode, and it should be enough. However, I believe that I have an error. Let's take a look. Yeah, of course. Let me have to add the new keyword, otherwise it won't work. I also spotted one more error. This also won't work. We have to add what is the event that we're listening to. Let's take a look now. Yeah, this is much better. As you can see, the local preview works. Let's also refresh the other browser. As you can see, this one is the private tab, and this doesn't have my permissions for microphone and camera stored, so I have to press the allow button. This one didn't require the permissions because they are being cached in the browser. And as you can see, we have a basic interface here, and let's assume that this is Joe and he calls Lucy. Let's select the only connected user. Let's press the call button, and seems like we have another error. I'm not gonna lie, it took me a while to find the bug, and it was a very easy one, so I'm just going to skip it. And I would like to showcase how the app works. So I select the user, I press the call button, and as you can see, this is my preview, and this is sent over the peer. And to illustrate you that it really works, I can, for example, press refresh here, and as you can see, both my local videos are still present, but due to the fact that the connection has been broken, this video that is sent over the server is just froze. And if I want to, I can call once again, and it works. And that would be it for today's episode of Expert Zone. I hope you enjoyed the episode and learned something about the WebRTC technology. Thank you, and see you next time.